So in this video we're going to look at solving an angle side-side triangle using the law of sines, and what we want to remember is from a previous video, this is the ambiguous case where we may get more than one solution. So what I'm going to start out by doing is just drawing the triangle, and then labeling it with what I know. So I'm going to have a triangle A, B, C with side little a, little b, little c. And we're going to catalog the information about the triangle. A equals, B equals, C equals, little a equals, little b equals, little c equals. So we're told that B is 100 feet, so I'm going to label that in 100 feet. We're told that C is 60 feet, so we'll label that in. So B was 100 feet, C was 60 feet, and angle C, we're told right here, is 28 degrees. So we're given angle C, 28 degrees. And I want to look at this. This is angle side side. So if the second side is shorter than the side adjacent the angle in an angle side side setup, angle side side, what we saw in a previous video is if this angle or this side length is shorter than this one, there's either going to be no solutions or two solutions. So if we assume that there's a solution because the side opposite C is longer than the side adjacent C, we're going to assume that we get two solutions. So I'm going to set up a second guy. The angle A is about, the angle B is about, the angle C is equal to 28 degrees. Little a we don't know, we'll probably have to approximate it, but we know B is 100 feet, and we know C is 60 feet, and again these are numbers that we will need to approximate during the solution process. So we're going to assume two solutions with the angle side side, given that the side opposite C is shorter than the side adjacent C. And so we just want to step into the solution process. So I see that I'm going to need to use these two rows because this gives me 1, 2, 3 pieces of information which will allow me to solve for the missing piece. So I'm going to start off by writing sine B, sine of angle B, the angle I'm trying to find, over the side that's opposite B, which is the 100, needs to equal the sine of the 28 degree angle that I know divided by the side that is opposite that angle. And then to get sine of B by itself, we would multiply both sides by 100. You get 100 divided by 100 is 1, so sine B would be by itself. And 100 over 60 is going to simplify, so in this step I'm going to take the sine inverse of both sides to get angle B out. So I'm going to add the sine inverse of 100 over 60, simplifies to 10 over 6, which is 5 over 3. So I'm going to get 5/3 the sine of 28 degrees. So that this angle right here is going to be an acute angle between 0 and 90, and that's going to slot up into the B position right here. But remember, when we solve a trigonometric equation and we take the sine inverse of both sides, we get two possible solutions. We get the acute angle, or we get its supplementary angle. So B could also be the supplement of this angle, or 180 degrees minus the sine inverse of 5/3 times the sine of 28 degrees. And this comes from the concepts we developed in the the series of videos on solving trigonometric equations. When we take the sine inverse of both sides, we get a solution that is an angle, and then we get also on the unit circle the supplement of that angle as a possible answer. Sine inverse solutions occur in supplementary pairs. So this angle I'm going to need to just go ahead and approximate it with my calculator, which I've already done. The only thing that we have to be careful about is that our calculator needs to be in degree mode because we're doing degree measurements. And when I calculated this measurement, I got 51.5 degrees about, so that's going to be 51.5 degrees here. Or we need the supplement of this. So when I calculate this in the calculator, the supplement is 128.5 degrees. And again, I'm approximating it, so I'm using the approximately symbol. 128.5 degrees. And then the moment I have the two possible angles from the two possible triangles from the ASS situation, I'm going to calculate my angles next. I have two of the angles, which means I can calculate the third. So my angle A is going to equal 180 degrees, which is what the angle sum of a triangle is, minus the sum of the two angles that I know, 51.5 plus 28 degrees. And when we crunch that in the calculator, we get 100.5 degrees. And this angle is also approximated because I've calculated it using an approximated number. Or I step over here, A is going to be 180 degrees minus the sum of the 128.5 degrees plus the 28 degrees, which equals, when we jump that into the calculator, equals 23.5 degrees. And I probably even should have here just said, hey, this is really an approximation, because I'm calculating it with an approximated number. I'm calculating this with an approximated number. So I get my 23.5 degrees. Now all I have left to do to solve my two possible triangles are to calculate my side lengths A. So this one I'm going to use A, put the thing that you don't know in that numerator position over the sine of 100.5 degrees equals, and I'm not going to use the information I have for B because that information has an approximated number. I'm going to use what I started with, where I had numbers that weren't approximations. So this is going to be 60 over the sine of 28 degrees. I multiply both sides by the sine of 100.5 degrees to get the A by itself. So we multiply both sides by the denominator here, sine of 100.5 degrees, which will give us a 1 times A is just A. And then we can approximate this number in the calculator, which I already did. Grab my second calculator. And that number is going to come out to be sine. I got to get the right calculator. Sixty sine. I don't see the calculation, so I'm just going to have to calculate it. So we're going to do 60 sine of 100.5 degrees divided by sine of 28 degrees. I like having it done ahead of time, but apparently I forgot to. So this is going to be 125.7. So 125.7 feet is the approximation. And then we need to do the same thing, same song and dance here. We're going to go A over the sine of the 23.5 degrees equals, we're going to use the unapproximated information, so equals 60 over the sine of 28 degrees. And then we'll multiply both sides by the sine of 23.5 degrees, which will cancel this, leaving us with A. And then we get the calculator approximation is going to be 60 sine 23.5, and then we're dividing that by sine of 28, and that's going to give us 50.9. It's going to give us 60.0 as our approximation, 60.0 feet. So we're going to do one more example of angle side side, but one where there's a unique solution. So here I have side length A equals 220, side length B equals 200, and angle A equals 40. So again, I'm going to start by just drawing the picture. and using the picture as a tool for helping me to think about the situation. So angle A is 40 degrees. So I have A equaling 40 degrees. Side A is 220 feet. So I know little a is 220 feet. I don't know angle B. I'll probably have to approximate it. I do know the side opposite B from here is 200 feet. So 200 feet here. So little b is 200 feet. And I do not know angle C. And I do not know side length little c. So I don't know either of those two things, and I'll probably need to approximate them. And I want to look at this carefully. Here I have angle, side, side. I have an angle, side, side situation, but the side that is opposite the angle is bigger than the side adjacent the angle, which means there's going to be only one solution. This is that situation where we know an angle. Here's the ray establishing the angle. I know a side adjacent that angle, but the second side is bigger than the first side. That's a horrible side. The second side is bigger than the first side. So when you go to construct that circle that we looked at in a previous video, it's only going to intersect our ray in one spot instead of two. So I should get a unique solution here. So I'm not going to bother doing another set of A's and B's and C's to get a second solution. I know there's only going to be one solution. What we'll do is pretend like we don't know that there's only one solution, and we'll see that even if we just work mechanically through the problem, not understanding that we shouldn't get two solutions, there's going to be a red flag along the way that indicates to you that there's a unique solution to this particular problem. So again, we're going to start with these two. I'm going to solve for angle B first, because I have 1, 2, 3 pieces of information letting me get the fourth piece. So I'm going to say sine B over the side opposite B is equal to the sine of 40 degrees divided by the side opposite the 40 degree angle is the 220 foot. And then we're multiplying both sides by 200. 200 divided by 200 is 1, so we get the sine of B isolated. We're going to take the sine inverse of both sides now, which will get the B out of the sine function. And so over here we'll have the sine inverse of, let's see, this is going to simplify to 10 over 11, so 10 elevenths of a sine of 40 degrees. So this is going to be an acute angle between 0 and 90 degrees. Remember, the sine inverse function gives us an angle between negative 90 degrees and 90 degrees, but we can't have a negative angle, so we're going to get an angle between 0 and 90 is what's going to happen to us here. So this is an acute angle, and if we're being mechanical, we go, hey, I know from the videos on how to solve trigonometric equations that when I take the sine inverse, I get an angle and its supplement. So I'm expecting two angles, 180 minus the sine inverse of 10 over 11 times the sine of 40 degrees. So let's say we are expecting to get two triangles, and we just mechanically set up to get that angle supplement. So now I can keep going. I can say, hey, this is approximately equal to, and I'm going to have to calculate that in a calculator. So grab a calculator, and that's going to be sine inverse. So I go second sine inverse on my calculator of 10 divided by 11 times the sine of 40 degrees, making sure my calculator's in degree mode. And when I do this calculation, I'm getting 35.8 degrees for this angle, 35.8 degrees. And it would make sense to take the time to think about, does this angle make sense? So if I've got a 40 degree angle and the side opposite is 220, if this side is shorter than this side, I'm expecting an angle shorter than 40 degrees, or smaller than 40 degrees, which I have. So this angle measure looks reasonable. Now let's go over and calculate this right here. So we go 180 degrees minus that. So I do 180 degrees minus that to get the supplement. And the supplementary angle here, the calculation yields 144.2 4.2 degrees, and this is going to give me a problem. So if I'm mindless and I just kind of keep chugging, I'm going to get myself in trouble. But what I want to do is pause. I have a triangle with a 144 degree angle right here. 144. Let's just put the 144. Well, 144 plus 40 is 184 degrees, and I haven't even added angle C in yet. So I have a triangle, a Euclidean triangle, for which the sum of the angles is greater than 180, but the sum of the angles of a Euclidean triangle needs to add up to 180 degrees. So I've exceeded the 180 degree measure, which tells me that this angle here can't be an angle on a triangle. This solution here is garbage because it causes the sum of the angles of the triangle to exceed the 180 degrees. So I knew to expect one solution, but if I just grind through it, I'm still going to get a red flag that the second solution I'm shooting for is garbage. So once I realize that this guy's garbage, we just focus on solving the single triangle that we have. So I've got this angle, so certainly I can get this missing angle by taking the angle C equals 180 degrees minus the 40 degree angle plus the 35.8 degree angle. And of course I did do it already, but now I've deleted it by typing over top of it. So 180 degrees minus the 75.8 degrees that we see sitting there. It's going to be 104.2 degrees, and that's actually approximated because I'm using an approximated angle to calculate it. There's my 104.2 degrees, and now I can get C, so it's going to be C over the sine of the angle C, 104.2 degrees, equals, I'm not going to use B in my calculation because I approximated that angle. I'm going to come up and use this original information. So it's going to be 220 over the sine of the 40 degree angle that's opposite side length A. Multiply both sides by the sine of 104.2, so times the sine of 104.2, which will leave C by itself. And so we'll get C is approximately, and we pop that calculation into the calculator, and we get 331.8. It looks like. I don't have my cheater readers on, so I might be seeing that 8 incorrectly. And this is going to be feet, so we get 331.8 feet is the triangle that we are interested in solving.